Okay, so today we're going to look at the second lesson on modulus functions, and we're going to look at solving equations where we have a modulus function involved. So one example is find the values of x, or solve the equation the modulus of 2x plus 3 equals 5. Now, you can try and do this without drawing it, but you shouldn't, because you must always draw these two things first. So what you actually want to do is you want to draw the lines y equals the modulus of 2x plus 3 and the line y equals 5 and find the points of intersection. So let's do a nice quick sketch. Hopefully we practiced this last lesson, so we should be able to do this. How am I going to do y equals the modulus of 2x plus 3? Well, think about the line y equals 2x plus 3. It would cross at 3. It's going to have a gradient of 2, so it's reasonably steep. So that's what the line y equals 2x plus 3 would look like. Now, if I want the modulus, I want the positive section. And when it goes below the axes, I reflect it, so any negative y values become positive y values. And as we did last lesson, we want to think where it crosses the x-axis, or where it touches the x-axis in this case, because it's no longer crossing it, it's just touching it. And in this case, that would be at minus 3 over 2. Then I'm going to draw the line y equals 5, which is just a horizontal straight line at y equals 5. And as we can see, there are 2 points of intersection. Now, how are we going to solve this? Well, if I think about the two different sections of this line, the first one that I'm thinking about is this line here. I want to find where this line crosses the line y equals 5. Well, if I think about what is the equation of this line, well, the equation of this line is just the line y equals 2x plus 3. So for this part, I want to solve where y equals 2x plus 3 meets the line y equals 5. So straightforward, I just equate the two equations, so I end up with 2x plus 3 equals 5. Rearrange it, take away the 3, divide by 2, and I get x equals 1. So at this point here, my x value is 1. Right, now the second point of intersection is over here. And it's where this line meets the line y equals 5. Now, in this case, what is the equation of this line? Well, it's not y equals 2x plus 3. Because for a start, it's got a negative gradient, it's going downhill. And what you realise is when you reflect a line in the x-axis, you're making all the y values negative. So if I think about the line y equals 2x plus 3, I am making all these y values negative. So the equation of this line that's been highlighted in green is actually y is the negative of 2x plus 3, because I'm making my y values negative. So it actually becomes the line y equals minus 2x minus 3, or a section of the line y equals 2x minus 3. So to find where the green lines intersect, I actually want to make minus 2x plus 3, so the negative of that modulus function, equal to 5. So running out of space here, I've got minus 2x minus 3 equals 5. Rearrange that, so I end up with minus 2x equals 8. So my x equals minus 4. So at this point here, my x is minus 4. And I can see from my diagram that looks about right. It's certainly the correct side of minus 3 over 2, which is where my modulus graph touches the x-axis. And so my two solutions for the equation, the modulus of 2x plus 3 equals 5, is x is minus 4 and x is 1. There's two answers. Okay, so let's have a look at another example. So this time I've got to solve the equation, the modulus of 3x minus 1 equals 2x. So, just like we did before, you really have to draw these. So, modulus of 3x minus 1. So, the line y equals 3x minus 1 would cross at minus 1. It would be pretty steep because it's got a gradient of 3. So, where it's above the y-axis, that's fine. But then it gets reflected. Okay, so it would cross at 1. And again, think where this modulus graph touches the x-axis. Well, that's going to be at 1/3. And then I want to draw the line y equals 2x. Y equals 2x isn't as steep as y equals 3x minus 1. So it's going to be a shallower line. It's going to go through the origin. So it's going to be something like that. Okay. And so again, we can see this is going to have two solutions. It's going to have one here and one there. So let's do the yellow one first, because that's the straightforward one. Because if we think about this yellow portion of my modulus line, what's the equation of that line? Well, the equation of that line is y equals 3x minus 1. And I want to know where it meets the line y equals 2x. So how do I solve where two lines intersect? I just make them equal to each other and they're in this form. So I can say 3x minus 1 equals 2x. So add 1 to both sides, take away 2x, and I get x equals 1 again. Okay, and again, if you look where it is, it's to the right hand side of where my modulus touches the x-axis. So actually a value of 1 looks a reasonable answer. Right, now let's look at the other one. So I want to know where this portion of the modulus graph meets the line y equals 2x. Now I have to think, what's the equation of this green portion of my modulus graph? Well, because it's the negative, because I had to reflect it in the y-axis, in the x-axis, the equation of that part is going to be y equals the negative of 3x minus 1. So effectively, the equation of that line, that part of that line, is minus 3x plus 1. Don't forget you're doing that negative of take away 1. So I want to know where the line y equals minus 3x plus 1 and the line y equals 2x meet. So again, equate the two. Minus 3x plus 1 equals 2x. Add the 3x, so I've got 1 equals 5x, so x equals 1/5. And again, if I look where it is, it's to the left hand side of that third where it touches the x-axis. 1/5 is less than a third, so it looks like it's in the right place. So the solution to my equation, the modulus of 3x minus 1 equals 2x, is x equals 1 or x equals 1/5. Got two solutions. Right, I'll do another one because this one becomes slightly different. And this is why drawing the equation is drawing the graphs are so important. So I'm going to draw my two graphs. So I want the modulus of x minus 2. Well, the line y equals x minus 2 would cross at minus 2. It's got a gradient of 1, so it would look something like that. So to draw the modulus version, it's going to look like that. Reflect anything under the x-axis, above the x-axis. So it crosses at 2. So I'm now going to draw the line y equals 2x plus 1. Well, it's going to cross at 1. It's got a gradient of 2 because I'm doing the line y equals 2x. That's going to be steeper than my modulus gradient. So it's going to be steeper. And so you can see this is one of those equations where we've actually only got one solution. So how am I going to find that one solution? Well, I need to know where the line y equals 2x plus 1 meets this portion of the modulus line. Now, which portion is that? Well, that's the negative portion of that modulus line. This is in fact represented by the line y equals the negative of x minus 2. So I want to know where y equals minus x minus 2 and the line y equals 2x plus 1 meet, because that's the point at which I'm looking at here. So I have minus x plus 2. Again, don't be forgetting this double negative business here. Equals 2x plus 1. Add x to both sides, take away 1, you get 1 equals 3x. So x equals 1/3. And again, that looks relatively right. I didn't actually put on there that touches the x-axis at 2, but having an x of 1/3 looks about right. Now, I'm going to show you why drawing the graph is important, because say I hadn't realised that and I accidentally used the wrong equation for the modulus line. So say I accidentally used y equals x minus 2 and y equals 2x plus 1, and I wanted to know where those two lines cross. And so I'd have x minus 2 equals 2x plus 1. Take away the x, and I'd suddenly have x is minus 3. Now, if I got that value, if I'd drawn the graph, I can look at the graph and say, I really must have made a mistake somewhere, because that point of intersection is not when x is minus 3, because x is minus 3 is somewhere down here. Somewhere down here. So I've made a mistake. Whereas by drawing the graph, for one, it's told you how many points of intersection there are, and for two, it's given you an idea of what that answer should be. And an answer of 1/3 looks like it is very sensible. Okay, so last one before I get you to do a few. This time I've got two modulus graphs, but we always start off exactly the same way. We're going to draw them. So the first thing I need is y equals the modulus of x plus 1. But to do that, I need to think about what the line y equals x plus 1 looks like. So again, it's going to cross at 1. It's going to have a gradient of 1. So it would look like that, where it crosses at minus 1. And so the modulus graph just looks like that. So I've got y equals the modulus of x plus 1. Now in purple, I'm going to do the modulus of 2x minus 3. What does that look like? Well, it would cross at minus 3 if I was doing the graph of y equals 2x minus 3. It's steeper than my previous one, so I need to make sure I draw it steeper. So I'm going to draw it a little bit steeper like this. Okay, crosses the y-axis at minus 3 and it crosses the x-axis at 3/2. And because it's the modulus, I only want the parts that are above the x-axis. Okay, so I need to reflect in the x-axis. Now again, we can see we've got 2 points. So I'll start with the first one. The first one is where this line intersects that line. And again, we have to think, is that the positive or the negative? Well, for both of these, that's the positive version of the equations of the line. So effectively, I'm doing x plus 1 equals 2x minus 3. So rearrange the equation, take away x, add 4, and I get 4 equals x. Does that look reasonable? Well, if I look at my line, yeah, it does. It looks quite sensible. Now look at the second one, and at this point I've got this line here and this line here intersecting. Actually, I'll make them both green. So I've got this line and this line intersecting. Well, if I look at this, it's the positive part of the y equals the modulus of x plus 1. So in that case, I've got the x plus 1. But if I look at the other line, if I look at this one here, well, that is the negative part of the y equals the modulus of 2x minus 3. So that is then the line. If I think about the equation of this line, the equation of this part of the line is y equals minus 2x plus 3 because it's the negative. So I have equals minus 2x plus 3. So I expand that negative out of the bracket first. So I've got minus 2x minus 3. Add 2x, take away 1. So I'm going to get 3x equals, take away 1 minus 4. So x is minus 4 thirds. Now my diagram probably hasn't got the gradients quite good enough there because it should suggest that it's on the negative side, okay? But when you're thinking about this, you only want to think about it relative to where it's touching this 3/2, where it's touching this x-axis, and it is further over, so that suggests that I was correct. Okay, right, so here's a few for you to have a go at. Press pause and I'll give you the answers when you're finished. Okay, so first one, fairly straightforward. You've got the positive version of the line crossing y equals 7, and you've got the negative version of the line crossing y equals 7. So you should have got x equals 5 or x equals minus 2. Okay, now with this one, you've got the positive version of the line that's the modulus, because remember, this is the positive version of the equation of the line, because the equation of the line is y equals 2 minus 5x, okay? And then you've got it meeting the line y equals 3x plus 5, and so you get an answer of x equals minus 3/8. Now, if you accidentally did it the wrong way round, you'd have got an answer for a value for x that was greater than 0. And that should have made you think from the diagram, I've made a mistake. Okay, so just make sure you use your diagram as your check mechanism. Okay, so on this one, we've got our modulus. So we've got the positive modulus cutting the line y equals 2x, and then you've got the negative of the modulus cutting the line y equals 2x to get you two answers. And very similar, but again, we've only got the one solution this time. So we've got the positive version of the modulus graph. So you've got y equals x plus 2 for this line here, meeting y equals minus 2x, and so you've ended up with minus x equals minus 2/3. Okay, so, and when we've got the two modulus signs, okay, you just have to, I mean, you quickly realise that when you've got two moduluses, well, if you do the positive equals the positive and then the positive equals the negative, it doesn't really matter which way around you do it, you get the same answer. But I always think it's nice to think about it. So you've got the positive version and the negative, and you've got the negative version and the negative, okay? So you should have got x equals 1 or x equals 7/5. Right, now they can turn them into inequalities. It's a slight difference, but it's a bit like when we did inequalities of quadratics. Again, you have to draw the picture to help you solve the inequality. So the first step is we've got to draw the picture. So just like before, do the line y equals 3x minus 1, crosses at minus 1, it's fairly steep, so it would look something like that. I want the modulus version, so it's going to look like that, crossing at 1 and crossing the x-axis at 1/3. Then we want the line y equals 5, which looks there. I know the scale isn't brilliant, but it doesn't matter. And so I've got 2 points of intersection. So just follow the motions. So for the first one, I've got the positive version of the line crossing y equals 5. So I've got 3x minus 1 equals 5. 3x equals 6, so x equals 2. And again, looking at that, it looks like it's in the right place. And then for the other, I've got the negative version of the line crossing y equals 5. So I've got minus 3x minus 1 equals 5. So minus 3x plus 1 equals 5. Take away 1 from both sides and divide by minus 3. And you get x equals minus 4/3. And again, if you put that on your graph, that looks a reasonable answer. Now, try and get rid of all this highlighting because I want to show you something else now. So now we've got to answer the inequality, okay? And the inequality wants us to say when the modulus is bigger than 5. So in other words, when the modulus is bigger, when the purple line is above the red line, okay? And that's for this, oh sorry, it's below because it's less than, sorry, ignore me, is when the purple line is below the line y equals 5, and that's this region here. Because if I think about, say, a value of x equals 1, my modulus value is less than y equals 5. If I think about x equals 0, my modulus value is less than 5. So to solve my inequality, it has to be in this range between x equals minus 4/3 and x equals 2. That is when the modulus function is less than 5. So my solution is minus 4/3 is less than x is less than 2. Let's have a go at another 2 of these. So again, how do we solve any inequality or any equation? We have to draw it, okay? So 2x minus 1 would look something like that. So if I want the modulus of 2x minus 1, it just looks like that, crossing at a half, or touching the x-axis at a half, and crossing the y-axis at 1. And then you've got the line y equals x. Well, y equals x is shallower, so I want a less steep solution. And I want to know, again, where these two lines intersect. So I have got the positive version of the line and the line y equals x. So to do those, I do 2x minus 1 equals x. So x equals 1, which looks about there. Try and squeeze it in. I should have drawn this a bit bigger. And then for the second solution, I want to know when the negative version of the modulus line meets the line y equals x. So for that, I say minus 2x minus 1 equals x. So minus 2x plus 1 equals x. So 1 equals 3x, so x is 1/3. So that's the value there, which is 1/3. Now I want to know when the modulus line is below the purple line. The red line is below the purple line because I want to know when the y equals minus 2, the modulus of minus 2x, I want to know when the line y equals the modulus of 2x minus 1 is below the line y equals x. And again, that's this little region here. Okay, if I look at this point here, my modulus line is above my y equals x, and I don't want that. I want when is the modulus line below. So again, I end up with a solution of 1/3 is less than x is less than 1, because it's for that little region in between here. Okay, now this one appears slightly different when we finish, but we start off exactly the same way. So I've got my line modulus of x minus 1. What does x minus 1 look like? It looks like that. So my modulus line looks like that, crossing at 1 and 1. Then I think about the line y equals 2x minus 1. Well, that's going to cross at minus 1. It's going to be steeper, so it's going to look like this. So it's one of those where we've only got one point of intersection. So I need to think, which of my lines do I need to use? Well, I've obviously got the line y equals 2x minus 1, but this is the negative part of my modulus line. So what I have is minus x minus 1 is equal to 2x minus 1. Because remember, if I think about just this line here, what's the equation of this line? It's the negative of the x minus 1. So it's y equals minus brackets x minus 1. Expand that bracket, equals 2x minus 1. Add x to both sides, add 2, so you get 2 equals 3x. So x is 2/3. And that looks reasonable from the diagram because that's there, 2/3. Okay. Right, now let's try and get rid of all these highlighting bits because I need the highlighter to think about what we need for the actual inequality now. And the inequality wants the modulus line to be below the purple line because it wants when the modulus of x minus 1 is less than 2x minus 1. So the red line has to be below the purple line. And where is that true? That's true here. Okay, if I think about, say, this point, my red line is above my purple line. So that's not right. Whereas I think here, my red line is below my purple line. So this is the region that I want. So to solve the inequality, it's just x is greater than 2/3. Okay. Now, I'm going to show you two more examples. And I'm not sure if these are still on the syllabus. They used to be on WJEC. The specification isn't very clear as to whether they are or not. So I just want to show you them very quickly, okay? And it's when you've got this situation here where you've got a bit of a modulus, but then you've got a bit extra added on. And we can't really solve these problems easily. We have to make them look like these, where you have a modulus equals a function or a modulus equals a modulus. You can't have a bit of a modulus with something else equals something else. So what you effectively have to do is you just have to rearrange to begin with to make it a modulus equals a function or a modulus equals a modulus. And how would you do that? Well, it's quite simple. You just take away 3 from both sides and suddenly you get modulus of x equals 2x minus 3. And now you can solve it, just like we did before. Another example is you might have something like this, which looks very complicated. So these were on the past papers before. And what you've got to do is you've got to think about this as a thing in itself. So it would be a bit like doing this. Rearranging this to make it x equals, well, what would you do? You'd add 3x to both sides. So you'd have 8x plus 1 equals 9. You take away the 1 and you get 8x equals 8. And you'd end up with x equals 1. Well, you can do exactly the same with this sort of thing, but you haven't got an x anymore. I've got the modulus of x plus 2. So I'll write it out again. X plus 2 plus 1 equals 9 minus 3 modulus of x plus 2. So the first thing I want to do is I'm going to add 3 lots of the modulus of x plus 2. Well, 5 lots of the modulus of x plus 2 plus 3 lots of the modulus of x plus 2 gives you 8 lots of the modulus of x plus 2 plus 1 equals 9. I then take away the 1. 8 lots of the modulus of x plus 2 equals 8. Divide by 8, and I've now rearranged it. So I've got the modulus of x plus 1 equals 1. And now I've got a modulus equals something. So now I can solve these. Okay. Now I haven't done any questions like that because I don't think they're on the specification anymore. They're not in the guidance notes. But I wanted to show you them just in case. But here are 4 inequalities for you to have a quick go at. Press pause and I will then show you the answers. Okay, so again, first one, draw it. You've got the positive version of the line and the y equals 7. You've got the negative version of the line and the y equals 7. So you end up with x equals 1 and x equals minus 5 over 2. And so your inequality becomes minus 5 over 2 is less than or equal to x is less than or equal to 1. And I didn't say this before, but just like any inequality, if that's a less than or equal, you use less than or equals, or greater than or equals. If it's just a less than, you use less than. Okay. The second one, again, draw your modulus graph, draw the graph of your line. Okay. Work out where the 2 points intersect. So with this one, you've got the positive version is meeting 5 minus x. You've got the negative version of the modulus equals 5 minus x. So you get your two values. And this time we want the modulus graph to be bigger than the line. So we want the red graph to be above the line. And when you've got the two separate regions, just like we do with inequalities for quadratics, we have to write them as two separate inequalities, because we say x is less than 1 or x is greater than 11/3. Okay, so number 3, again, fairly straightforward, but we've got the two separate regions, so we have to write them as two separate inequalities. And the final one, okay, so you got to remember which side are you using. Oops, I've got this a bit too big. All right, and this is the negative part of the line y equals the modulus of x over 2 minus 1. Okay, because that was a bit that had been reflected, which is why it's always really nice to draw these dotted lines on and almost imagine where the original line was to begin with, because that helps remind you which bit of the graph you're talking about. So you're doing when minus x over 2 minus 1 equals minus 2x, and so you end up with a value of minus 2/3. There's only one value to this, there's only one point of intersection, and you want to know when the modulus graph is below the line. So that's when x is less than minus 2/3. Okay, so that's it for this lesson. Have a go at the worksheet, and I will see you next time.